In this video, we're going to practice computing positive exponents of numbers. Remember that to raise a base to an exponent means that we just need to repeatedly multiply the base however many times indicated by the exponent. So here we're going to compute the values of the following exponential expressions using repeated multiplication, by repeatedly multiplying that base according to how many times indicated by the exponent. The first one is pretty simple. 2 to the first, that just means multiply 2 by itself one time. So that's just 2. 2 to the second power, on the other hand, says to multiply 2 by itself 2 times. So 2 times 2. And 2 times 2 is just 4. So 2 to the exponent of 2 is just 4. Alright, how about 2 to the exponent of 3? Well, 2 to the exponent of 3 just says to multiply 2 by itself 3 times. So 2 times 2 times 2. 1, 2, 3. And we just need to compute that. So 2 times 2 is 4. And then we're multiplying that by 2. So 4 times 2 is just 8. So 2 to the third power is just 8. Lastly, 2 to the exponent of 4 just means to take 2 and multiply itself 4 times. So 2 times 2 times 2 times 2. 1, 2, 3, 4. And that's equal to, well, taking the first two terms, 2 times 2 is 4. So 4 times 2 times 2, still got those remaining times 2's to do. And 4 times 2 is 8. So we've got 8 times 2, and 8 times 2 is just 16. So there we go. 2 to the exponent of 4 is 16. Alright, now let's practice going the reverse direction. Before we were taking an exponentiated expression and multiplying it out. This time we want to take each of the following multiplication expressions as a base raised to a positive exponent. Okay, so first of all, 3 times 3. The base is 3. That's the number that's being multiplied. And then we need to raise it to an exponent. What exponent? Well, the exponent just tells us how many times we're multiplying it. So 1, 2. We're multiplying it twice. The exponent is 2. So 3 times 3 is written as 3 squared. Alright, same idea for 5 times 5 times 5 times 5. The base here, the number being multiplied, is 5. And then the exponent is how many times we multiply it. So 1, 2, 3, 4, 5 to the fourth. Again, same idea for negative 2 times negative 2 times negative 2. The base here, the number being multiplied, is negative 2. And the exponent tells us how many times we're multiplying it. 1, 2, 3. So negative 2 to the third power. Last one, 1/3 times 1/3 times 1/3 times 1/3 times 1/3. That's a lot of 1/3. 1/3 is being multiplied, so 1/3 is the base. And how many times is it being multiplied? Well, 1, 2, 3, 4, 5. 5 times, so exponent is 5. And there we go. That's the base raised to the positive exponent for this multiplication expression. Alright, here are some final exercises. So we want to compute the values of the following exponential expressions. Okay, first one is 5 to the third. So that tells us that we take 5 is the base, take 5 and multiply it by itself 3 times. 5 times 5 times 5. Let's go ahead and figure out what this is. Well, we know that 5 times 5 is 25. So this is just 25 times 5. And what's 25 times 5? Well, we can just multiply it out, set it up. How about 25 times 5? Let's multiply. 5 times 5 is 25. And then 5 times 2 is 10, plus 2 is 12. So 125. Alright, next one is negative 1 to the exponent of 6. So that's just negative 1 times itself 6 times. Negative 1 times 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 negative 1. And let's count that up. 1, 2, 3, 4, 5, 6. Good, we've got it written out correctly. And now let's go ahead and multiply. Well, negative 1 times negative 1, the negatives cancel, and then we just have 1 times 1, which is just 1. So we've really just got 1 times negative 1 times negative 1 times negative 1 times negative 1. Okay, And then 1 times -1 is just -1, because 1 times any number is just that number. So we've just got -1 times -1 times -1 times -1. Alright, we'll keep on going this way. So -1 times -1 is just 1. Negatives cancel out. 1 times -1 times -1. And then 1 times -1 is just -1. So -1 times -1. And then lastly, -1 times -1 is just 1. Negatives cancel out, we're left with just 1. Okay, how about -3 to the 5th? So let's write it out. -3 times -3 times -3 times -3 times -3. Alright, so -3 times -3 is just, well, negatives cancel, and then we've just got 3 times 3, which is just 9. So 9 times -3 times -3 times -3. And we know that 9 times -3 will be a negative number, so negative, and it's the negative of 9 times 3. 9 times 3 is just 27. So negative of 27, then times -3 times -3. Okay, so now we'd have to compute what's -27 times -3. Well, the negatives will cancel and we'll just have a positive number, but we still need to figure out what is 27 times 3. And we can do that up here. So how about 27 times 3 multiplied out? 3 times 7 is 21. 3 times 2 is 6, plus 2 is 8. So 81. So 81 times -3. And for the last multiplication, there's only one negative sign, so we know that's not going to be canceled out. Our answer will be negative, but we need to compute what is 81 times 3. And let's do that up here again. So 81 times 3. 3 times 1 is 3. 3 times 8 is 24. So -243. Alright, here's the last problem. 3/4 to the 4th power. So that's just 3/4 times 3/4 times 3/4 times 3/4. 1, 2, 3, 4. We're good. Okay, so now we just have to multiply. So let's do the first multiplication. 3/4 times 3/4. We just have to multiply the numerators and the denominators separately. So numerator 3 times 3 makes 9, and denominator 4 times 4 makes 16. Okay, so that times 3/4, then times 3/4 again. Alright, so again multiply the numerators. 9 times 3 is 27 over, and then 16 times 4. Why don't we go ahead and compute that off to the side. So 16 times 4. 4 times 6 is 24, and then 4 times 1 is 4, plus 2 is 6, 64. So 27 over 64, and then we have to multiply that by 3/4 again. Okay, so 27 times 3 goes in the numerator. We already did that. We found that 27 times 3 is 81. So that's 81 over, and then 64 times 4 we still need to figure out. So why don't we do that to the side here? So 64 times 4. 4 times 4 is 16. And then 4 times 6 is 24. Plus 1 is 25. So 256. And there we go. That is 3/4 raised to the 4th power. Now we know how to compute numbers raised to positive exponents. And in the future, we'll also learn how to compute numbers raised to negative exponents.